This video is going to be a short little video of completing the GoPro camera case that I did in the last couple of videos, and just showing how, you know, the machine work on this clasp thing that holds the case closed. And also I'm going to go into a little bit about what I'm going to show in some future videos. So let's get to the machine work on this clasp thing, and then we'll get to that other stuff. I had to set up a few parallels in this vise fixture that I made in the last video. So here I'm doing that, cleaning the jaws. I use little magnets to hold my parallels in the vices usually. Started doing this in the horizontal mill because of the top parallel would fall down if you didn't hold it up. So putting the part in here with a little stop thing that comes with the vise. First tool, 1/2-inch end mill, just to rough off the bulk of the material. And this view is a little bit blurry, but the next view you can see a little better. Just roughing off around the clasp. The reason I held it in the vise this way is because I'm going to come later and cut it off with a circular saw, and it gives me clearance for the saw to go around the end of the part on the, you know, with the vise line. And also I can see it better because it's closer to me, to the window of the machine. That's the only real reason for this, setting off center. And I clamped a little piece on the opposite side of the vise, as you see, to kind of balance the force on the jaws. It's kind of important to do that when you clamp things off center in the vise, because there's these Kurt vices, or this style of vice, the back jaw has quite a bit of play in it, from, you know, side to side, I guess you'd say, or it'll rotate the back jaw if you don't have something balancing the force on the other side of the vise. I showed that in one of my earlier videos. I don't really remember the name of the video. I think it was squaring up a block of aluminum. And I go into more detail on the deflection of the jaws of the vise due to forces off center in the vise. So this is a 1/2-inch end mill, just roughs off the bulk of the material. I come in with a 1/4-inch end mill to finish around the outside of the part here. And I believe this end mill also roughs the center slot for the dovetail. Kind of a tapered dovetail on this catch so that it holds, the harder you shove it further over on the case, the tighter it gets, kind of like a wedge. So that's finishing the outside of the part. Then it comes in here, like I said, and it roughs the slot for the dovetail slot, I guess you call it. So this is the only part of the machining in the video that I actually sped up. The rest of it is at real time, right there. Now it's back to real time. And of course I sped up the tool changes of the machine. But other than that, everything else is running at regular speed in the video. So this tool is a chamfering tool. It can chamfer on the front and the back of the tool. So I'm chamfering the top of the part just to break the edge. I think it's a 20 thousandths by 45 chamfer. And then I'm chamfering what will be the top of the part after it's parted off around the perimeter of the part here. And I come in with the dovetail tool, cut the dovetail. So that's the dovetail, and then I think that's it with the part, except to cut it off with this circular saw that's coming up next. This is the only saw I had that would clear things. It's kind of a wide saw blade. I think it's 156 thousandths wide, carbide inserted type of thing. so I had to allow clearance on the vise, like I said before, to cut this off like this. I'm just parting it off, but I'm leaving a little tab so it doesn't go flying into the chip conveyor of the machine, and then I have to hunt for it in the chip conveyor. So here it's done. I'm going to open the door and break it off of there. This is a pretty common way I do things on the mill. We do things in the shop here. We machine the whole part complete and then cut it off, but leave a little tab so you can kind of just break it off of there. So there you can see what's left of that tab on there. And then this next view I broke it off with pliers. And what we usually do is just sand it. Well, on an aluminum part like this, you can just sand it on a flat surface with some wet and dry sandpaper and sand that off, usually. Here's the way I held the case together to film this whole video, because it didn't have this latch thing to hold it together until after I made this video. So that's more or less the completed camera case, except for my film material I'm waiting for to come in the mail. Here's what we're going to go into in some future videos. I have 6 of one of these and 6 of another of these parts to make that they're both pretty much the same, except this flange is bigger in diameter and the holes are larger on one set. But other than that, they're almost identical. And they all have this same API face seal groove on the flange here, but normally with an API seal, you don't have this boss in the middle here, and so it's pretty standard measuring instruments that go across here and measure. What you usually measure is the intersection point of this angle and this face. It's somewhere in this chamfer, but you can measure it with a particular instrument, and then you would measure the width of these two angles. And also you're going for an imaginary intersection point here that's kind of in space, so you really can't get a measuring instrument on it unless you have a way to measure these angles in relation to the face. So the way they typically do this is they have this rod with these end pieces with balls on it, and you push it in here in a certain way. It's kind of like a snap gauge for measuring a bore, and you push it in there, and then you mic across the balls, and they have charts that calculate the width for that. And then you do the same thing for the width measurement with these two balls. Or I have these gauge maker instruments that use dial indicators to do the same thing, so you don't have to be quite so precise on how you shove the gauge balls in there on the other ones. So in order to measure this with this boss sticking out there right here, I have to make some special instruments. So this one is going to be the one to measure the OD with across the outside, angle here and here of this groove, and then this is going to be what we're going to measure the width with, which is going to be measuring these two angles here, and then you're going to project the imaginary intersection points between the faces here of those angles. And also, in order to do this, because these are reference tools, reference gauges, you have to make a standard to set them on. So I'll have to machine a groove in the end of a scrap piece of material that to the right dimension, so that I can actually set these tools up. So I'm going to be showing a little bit of that in future videos. The part itself, I kind of wish I could show some of that, but this customer is pretty secretive about all of that, so I really can't go into that in too much detail. Maybe a few little sections of the machine work. So I'm sorry, but I can't really show you too much of that, but I can show you about these measuring tools here to measure the groove and how that's done. and I'll go into how it's typically done when I measure the standard that I've set these tools on. So that's what I'm hoping to make future videos on, and what's coming up.